I'm Terry Bradshaw. From emerging technologies and financial strategies to the latest healthcare developments, you would be surprised by the many factors coming into play. Welcome to Today in America. Technology may have been born from the synergy between science and industry, but its ultimate value lies in the power it exerts to better people's lives. Let's learn how the latest technologies are advancing the human cause.
Photographs of virtually every neighborhood in the country are available on the internet. But there is still a need for ultra-high resolution imaging of large geographical areas for purposes such as environmental stewardship, agricultural research, large-scale land development, and civic planning. Called photogrammetry, the technique involves the use of three-dimensional imagery to capture a highly detailed map of features on the ground. With this mapping data, it's possible to get precise measurements of land, its topographic profile, and any existing man-made features such as roads, bridges, or buildings.
With today's technology, photoscience can achieve accuracies approaching 2 inches from the air. We can actually achieve greater accuracies with our new mobile mapping unit. This is particularly beneficial for such projects as highways, airports, and urban street renewal, where placing people in harm's way and achieving accuracies is very, very costly.
A close cousin to radar, LiDAR is a relatively new technique of light detection and ranging. Mounted on an airplane or helicopter, LiDAR is capable of mapping a wide swath of ground elevation data with each pass, and this patchwork can be digitally woven into a detailed view of the land surface from a few acres up to many square miles.
We've mapped the Colorado River and the Grand Canyon by flying 3,000 feet below the rim, mapped the Panama Canal, and provided imagery for the southern quarter of Louisiana after Hurricane Katrina. Aerial acquisitions have varied from low-altitude helicopter flights at 300 feet to high-altitude missions in twin-turbine aircraft at 30,000 feet or more above ground.
The U.S. Department of Agriculture has contracted for the mapping of vast portions of the country in 2 versions. A picture of the terrain during the summer growing season is obtained in what's known as a leaf-on survey. This is followed in the winter months with a leaf-off version when the trees are bare and more detail of the land beneath them can be seen. This before and after data can reveal much about the condition of the land, precipitation, and drainage patterns, as well as growing cycles.
Photoscience is currently involved in one of the largest environmental monitoring projects of its kind for the U.S. Department of Agriculture National Agricultural Inventory Program. During the summer growing season, we fly several multi-state regions and create what is commonly referred to as digital orthophoto maps.
When a disaster strikes, like a hurricane or the massive oil spill in the Gulf of Mexico, high-definition images help track the effects and guide cleanup efforts. In order to be an effective tool during or after a calamity, a pre-existing map of the terrain under normal conditions is vital. Weeks before the offshore drilling mishap, Photoscience had just completed a thorough survey of the region for the study of seagrass and other natural organisms that thrive in the shallows along the coastline. The balance between seagrass and algae growth serves to measure the ongoing health of the aquatic ecosystem in the Gulf.
Over the past several years, Photoscience has been delivering aerial photography and mapping services along the coast of Florida to understand and mitigate the effects such as oil spills can have on our environment.
LiDAR technology provides aerial imagery which is instrumental in the planning of environmentally friendly development.
Photoscience is involved in several projects with the U.S. Geological Survey, the National Oceanic and Atmospheric Administration, and the Federal Emergency Management Agency. These projects include such environmental monitoring of coastal erosion, hurricane, disaster recovery, and land use, land cover, endangered species.
In order to carry out our role as stewards of the land, we need to know what's there. Now that information is available at a level of detail never seen before.